Welcome everybody to this HIOKI Europe webinar on UPS inspections. My name is Roy Hali. I'm a product marketing specialist and will be your host during this webinar. We start with a short introduction of HIOKI Europe. The company was founded in 1935 and is known for its quality and a wide range of test and measurement products, varying from digital multimeters and clamp meters to high-end power analyzers, memory recorders, and battery test solutions. Today, we will introduce our solutions for UPS inspection using the battery tester BT3554-50. We will start with a brief history of HIOKI and the battery testers. After that, the actual situation, kind of a case study we will do as an example of how you can use the battery testers in the most efficient way. And after that, we will have a short demo with some tips and on how to use the instrument and how to manage the data that will be generated by measuring. Next slide, please. As you can see here, HIOKI started already 35 years ago with solutions for battery testing. Nowadays, we have a wide range of battery testers, and among them are also solutions for the development and production of lithium-ion batteries. But today, we will look more in detail to the testing and inspection of batteries using the handheld products. 25 years ago, the first handheld battery was introduced by HIOKI. So we already have a history of 25 years in handheld battery testing. This year, we have introduced the latest version of that one, and that's the BT3554-50. Now we're going to enter the technical part of the seminar, of the webinar. And for that, I would like to introduce my colleague, Hide. He is an application engineer here at HIOKI Europe and will take you through the presentation and the demo of the instrument.
Thank you, Roy. And thank you for joining our webinar. My name is Hidekazu Masuda, application engineer with HIOKI Europe. So today I will introduce the HIOKI battery tester BT3554-50. I will try to provide you with meaningful information based on our experience. So let's get down to business. Today's main topic is the UPS maintenance. A UPS must work reliably in the event of power outage or other power disturbance to protect your critical systems. Unfortunately, a battery is a not perfect device. It is based on chemical reactions and will always degrade. Moreover, not all batteries degrade in the same speed. As you can see in the picture, there are usually many battery cells used in the UPS. Sometimes just one cell can deteriorate to an extremity. So it is necessary to check the health of the battery cells regularly. According to the IEC standard for backup battery maintenance, these tests are required: battery cell and system voltage, the internal resistance of cells, and conditions of connections, temperature, and battery capacity. Doing this test, you can find degraded battery cells and change it to a new one to keep your UPS system healthy at all times. So regular inspection is important, but how often we should check the UPS? The NERC shows these guidelines how often we should check the lead acid battery conditions. For example, it says every 6 months, we should inspect the conditions of all individual units by measuring battery cell units internal ohmic value. So now you don't need to remember this chart, but the important things to remember is that you need to measure the internal resistance of all battery cells in the UPS. The next topic is why we have to check battery internal resistance. There is a correlation between the battery capacity and the internal resistance of lead-acid batteries. Now I show typical characteristics between the battery capacity and the internal resistance. Please look at the blue line. This line shows the battery capacity. So the repeated charging and discharging or passage of the time will degrade the capacity. The red line shows the change in internal resistance. It tends to increase as the battery capacitance decreases. So therefore, internal resistance is an indicator to know the battery deterioration. Here is an example. If battery resistance exceeds 1.5 times large values compared to the initial value, you should start planning to replace the new battery cell. If it's more than 2 times large values, you should replace it with a new one right away. So this 1.5 and 2 is just reference value. So this threshold is depending on the battery type. So when choosing a battery tester, we recommend one is that can make the pass or fail and warning judgment with 2 thresholds, like this chart. If you have been paying attention to this slide, you may have noticed that text 1 kHz. In the next slide, I will explain why 1 kHz is used for the internal resistance measurement. So why 1 kHz AC test signal? I would like to tell you why that reason. You may think DC resistance is more important because the battery is a DC power source. Actually, DC resistance is important. However, the purpose of the maintenance is to find the deteriorated battery in the UPS system with speedy. The methods for 1 kHz signals are faster than DC measurement method. And there is no discharge of the battery during the test, thanks to the small test signal. Test speed is important for the battery manufacturer and also for the maintenance situation. As a result, the 1 kHz inspection has become the industrial standard. When we look at the datasheet for the lead-acid batteries, it lists the 1 kHz impedance like this. So please remember that the 1 kHz AC test is a quick way to measure the internal resistance of a battery. Okay, so let's think about the challenges in the battery testing. As you can see, many batteries in the room. For example, the operator needs to test all battery cells. So you can imagine that it takes a lot of time when measuring such a large number of batteries. It is clear that you should have a high-speed measurement battery tester. Also, you need to record the data. This is because it is a common requirement to create a test report to show that all batteries are healthy. And by keeping the data, it is also possible to know the trend of the changes in the internal resistance of individual cells. However, it is very hard work to manage these battery data and location information. This is challenging for those who create report in the back office. However, the test operator, as you can see in this picture, sometimes batteries are located backside of shelves. In this case, it is difficult to access to the battery terminals. And also the UPS has a high voltages, so the test operator has a risk of electrical shock during the test. So as you can see, there are several challenges with battery maintenance. And now HIOKI's battery tester is a solution to these challenges. Okay, this is our battery tester. This is product overview. The HIOKI is thinking to minimize working hour is important benefit for the battery maintenance people. The basic test items for the battery maintenance are the battery voltage, the internal resistance, and the temperature measurement. These parameters can be measured while the UPS is online, and it can judge the battery conditions using the comparator function. These results are automatically stored in the internal memory. Test operator do not need to touch any keys during the test. One of the unique features of HIOKI battery tester is support for the Bluetooth option. If you attach Bluetooth adapter, you can use the mobile app. This app can create a test report on your smartphone or tablet very easily. And functions, the measurement guide system and the profile data registration is useful for the data management. These two features provide customers with the benefit of minimizing the work time of UPS inspection. I will explain details from next slide for these two features. From now, I will explain our data management solutions for the battery maintenance. Our battery tester can store 6,000 measurement data and 200 different thresholds in its internal memory. But let's imagine, how can you handle such a large data? If the test operator stored the data without any rule, it would be very difficult to handling the data. To solve this problem, we provide software solutions. One is the mobile app, Genect Cross, and other is free PC application software, Genect One. I will show you model case to explain clearly how Genect can help the people of maintenance people. This is the model case. Here is a company called ABC Data Center. And now they have 1,500 batteries installed in their UPS room. The maintenance company needs to make sure that the resistance and voltages all batteries within the threshold. And they must report the batteries that need to be replaced. An important part of the data management is to link the measurement result with location information, such as the room number and shelf numbers and battery identification numbers. It is not an efficient way to write down the battery number and the locations in the notebook on the test site. To reduce the data handling time, it should be prepared data format in advance. For the step one, let's register the profile data and threshold in Genect One. The profile data is a location of the batteries and the battery type and the battery numbers. Registering these informations by linking it to the battery tester's memory number, the data can be instantly matched after the measurement. It will also make it easier to plan your work by defining the number of batteries and their locations. In this way, the back office guy can prepare the profile data in advance. There is no need to operate the battery tester itself. Okay, the next step is to transfer the profile data and threshold data to the battery tester. In this model case, there is 1,500 batteries, so he should split the jobs into tasks among test operators. It is easy to transfer the selected profile data using the Genect1. There is two ways to transfer the data to the battery tester. One is the USB or Genect Cross. The Genect Cross is the mobile app. If you use this app, you can share the profile data in test site without connecting PC. So it is very convenient to complete the setup on the test site. You can reduce the time to go to the back office. Okay, the test operator arrives at his test site and he starts measuring according to the profile information. Please see this picture. The profile data links to the actual UPS room like this. For example, you can create profile data for each share levels. The test guy just press the guide button and select the start profile number and threshold. Then they can start the test. The battery tester display the battery numbers and test operator measure the correct battery cells, and then device shows the result. You can test while checking the battery number, reducing the risk of getting the wrong cell result. While the guide function is operating, all keys are disabled. So therefore, there is no need to worry about the misoperation of the device. Okay, they finish the measurement. After the test, the measurement data can be immediately transferred to the back office using the Genect Cross application. The data can be sent via email or cloud service via smartphone or tablet. You can also double-check the recorded data on your smartphone. So colleagues in the back office can instantly create test reports because the data is already linked to the profile data information. It is also easy to compare with the past result. The template for the test report is available on the Genect1. This report function will save time making test report. This test report includes measurement result, and judgment result table, and graphs. If you already have the past data, the trend graph is available. If customer wants to use their own report format, you can arrange the data on Excel or Word files. Okay, this is the HIOKI's proposal to minimize the battery maintenance workflow. Okay, from now, I introduce another features of our battery testers. Well, at first, the Excel direct input function is the advanced features of the wireless Bluetooth adapter. You may want to use your own test format, such as Excel sheet on the side, and it needs to directly input the measurement data on your Excel sheet. Excel direct input function is the same behavior as the wireless keyboard. So if you measure the data, automatically enter the numbers and the units in the Excel sheet. If you want more detail about these functions, you can find the video on the YouTube. So please check our YouTube channels. Okay, next, our battery tester has a good measurement performance. because our battery tester has high noise resistivity. During the UPS operation, there is a harmonic noise from the inverter. If the frequency of the inverter noise is close to the measurement frequency of the battery tester, a stable measurement is not possible. To solve this problem, HIOKI developed a noise reduction technology. If you use these functions, the device detects the noise frequency and beginning of the measurement and start the measurement, and you will get the very stable measurement result like this. Okay, and another unique feature is the audio guidance functions. If you can bring your smartphone to the test site, you can use the audio guidance features. The Genect Cross app will guide you the battery numbers and the measurement result by sound. The advantages of audio guidance is no need to check the battery tester display during the test. The audio language, it depends on the language setting of your smartphone. Now, English, Germany, Italy, French, and Spanish is available. And test probe is a very important accessory for the battery maintenance, battery testers. We have a good test probes for the narrow space. We recommend L2020 L-angle type probe because the L-shaped design significantly improves ease of use when inspecting battery installed in confined locations. However, it is not always possible to reach batteries in the backside. We provide extension rod as special option for this. This rod can attach the L2020 probes like this drawing, and it can contact the battery pack placed in the back side of the shelf. If you are interested in this extension rod, please contact to the local distribution partner or our sales responsible person. Okay, this is the product lineup. So simply you can choose between the two types of probe kits, straight type probe or L-type probes, or and with or without Bluetooth adapters. Okay, and this is the final topic, that is the FAQ. The customer asked us frequently, can I measure the internal resistance of lithium-ion batteries using the BT3554 series? Yeah, that's a good question. In principle, the BT3554 series can measure the internal resistance of LIB. However, the result will include the resistance of BMS. BMS is normally attached on the LIBs to control the charge and discharge for the safety reason. In addition, lithium-ion battery exhibit very small changes of internal resistance despite battery deterioration. This means that it is difficult to find deteriorated LIBs using this battery tester. At least you can probably find that a cell is faulty in its resistance is clearly different from the other cells. So in maintenance purpose, BT3554 is not best solution for LIB UPS at the moment. Okay, thank you for listening to my presentation part. Now, I want to show the short demonstrations. Please wait to changing the slide. Okay, now I will show you the short demonstration of HIOKI battery tester. here is the battery tester BT3554-50. Now the L-type angle probe is connected, and temperature sensor is also connected. The temperature sensor is used for checking the UPS room temperature. And now here is the 12-volt lead acid battery as a battery sample. Okay, the battery tester can measure the internal resistance of battery and battery voltage and temperature at the same time. Okay, now I can show you the measurement example using this battery. Just contact the two probes on the terminal, and now it shows the measurement result. Now I don't touch any keys of this device because it has an auto hold function. So auto hold function is automatically for the values, and so you can check the measurement result easily. And the actual UPS maintenance situations, you have to test multiple battery cells. In that case, the auto memory function is very useful. The auto memory function can store the data in internal memory of the device automatically. And now you can see the memory number on the top of the display. Okay, now I try to measure this battery 5 times. So please check the measurement speed. Okay, now I start. Number 1, it's saved. Number 2, saved. Number 3. Number 4. And number 5. So as you can see, the measurement speed is quite good. And of course, you can check the measurement results in the device. Now here is 5 data, and now it shows almost same numbers. So which means that this device has a good repeatability for the measurement. Okay, this is a very basic about how to operate this device, how to use the battery testers. Now, I want to show another tips for the measurement. This is a dummy bus bars. In the actual UPS side, these bus bars are used to connect the batteries each other's. And when you check the battery health, of course, you have to contact from the bus bar, not directly to the battery terminals. Okay, now I can show you the judge example for using our comparator functions. To use the comparator functions, you have to set the threshold for the internal resistance and voltage levels. It's already set up in advance. Okay, now I try to measure from using this dummy bus bar. Sorry, I have to check the connections of the cables. Oh, okay. That's not my story. Sorry. Okay, here is bus bars, and you have to check the resistance via bus bar and board. And now device shows a pass. Okay, but the connection resistance is required for the battery maintenance, because if the connection has a problem, you can't judge correctly the battery resistance. Maybe you already noticed, if the one board has a loosen, we will get a different result. Okay, now I show you the measurement. Yeah, now it shows a warning result, and the measurement measured internal resistance is 96.4 milliohms. It becomes larger than previous result. So which means if you judge this battery has a problem, that's not correct. The problem is the connection of the battery bus bars. So let's check the connection resistance using the battery tester. This side, it shows 0.5 milliohms. That's a very good conditions. But how about this side? Now it's not stable because the board is risen. Yeah, we get 15.3 milliohms. That's a completely different values. So the connection resistance is an important test items for the battery maintenance. So you should check the contact resistance using the battery tester, because the battery tester is very good to check the low resistance values, as you can see. So now I fixed the board gain and check the contact resistance. Yeah, now it shows a less than 1 milliohm. And one point for the judgment and making a threshold for the judgment. Usually the UPS using such a plastic covered board for the safety reason. And then normally it has holes on the top to contact the probes for the maintenance purpose. But this plastic covered board has a little bit large connection resistance compared to the other type board. Okay, let's compare to these different type board connection resistance. First, I checked this one. Now it shows 0.9 milliohms, less than 1 milliohm, very small resistance. How about this one? Now it shows 3.4 milliohms. So as you can see, this board has a different contact resistance. And of course, when you make a threshold for the judgment of the battery test, this board connection resistance is affect to the measurement result. So please double check the resistance after you installing your batteries in the UPS. And after you installing the batteries, you should get the initial values, including the board and bus bars resistance. So maybe you can get a more correct judgment result using our battery tester. Okay, this is my short demonstration is done. If you're interested in our battery testers, we are preparing some demonstration units for your trial. So please contact our distribution partner or sales managers.
Okay, Hide, thank you very much for the presentation and for the live demo. At this moment, we have 2 questions in the Q&A box. So if you have any questions, please, this is probably the right moment to change and to put your questions in the Q&A box so we can answer them. What I would like to do is now to conclude the presentation and explain what the purpose has been for this webinar. We have shown you the BT3554 and the support software and the structure that we use to prepare the measurement and to do the measurement and to do the report generation. This way, you can reduce the time to do your inspection dramatically, and therefore it is a very useful tool to do efficient inspections of the UPS batteries. Further, during the demonstration, Hide has shown that it is necessary also to check the resistance of the bus bar, because only when you have the resistance of the bus bar included into your measurement, it's possible to do a good judgment of the internal resistance of your battery. Okay. Then we are now ready for the Q&A session. I have two questions from Philip Matthews. The first one is, why does HIOKI use AA batteries instead of a lithium-ion battery, for example? Are you going to answer, or shall I answer?
So, which means that our battery tester is a battery powered, but okay, I try to answer it. So one of the reason is AA battery is more easy to get from the many market. So customer can easily get new batteries. Of course, the rechargeable battery is possible to use for this device, but it has one problem. This is a battery indicator. This battery tester has a battery indicator, but this is based on the AA alkaline batteries performance. So if you use rechargeable batteries, this battery indicator doesn't work properly. But yeah, that's possible.
Okay. I hope that answers your question, Philip. And the second question is also from Philip. Do you have a comparison with internal resistance with different probes? What is the expected difference between an L2020 and a clamp probe, for example?
That's good questions. So, especially for the small resistance measurement, the difference of the probe affects the measurement result. In that case, we recommend to perform the zero adjustment before starting the measurement. And basically, our battery tester official probe is how can I say, that's the same design for the tips, and these two probes doesn't have a many big difference. Of course, our battery tester is specified the accuracy without doing the zero adjustment. So you can get very correct accurate numbers without zero adjustment and using the different type probes.
Okay. But the clamp type probe, so that's probably the crocodile clamp.
Yeah. That's right.
Then there will be a difference in resistance, and then we advise to do a zero adjustment.
Yes, zero adjustments. If you do the zero adjustment, you will get the much more correct result.
Yeah. Okay. Those were the two questions. So if we go further into the presentation. Next slide, please.
Okay.
Yeah. Here you see some information about the material that is available as additional information. There is a landing page of the product, and from the landing page, basically you can get all the information that you require. But of course, it's also possible to contact your local representative or the sales manager of HIOKI to answer your questions. And then I would like to thank you for participating in this webinar. On the right-hand side, you see all the members of the product marketing support group which are there to support all our sales, but also customer questions. So if you have any questions, you can send them to hioki@hioki.eu. And for local information about local distributors, you can find them on our website as shown in the link below. And then the last information that I would like to share with you is our next webinar. The next webinar will be a completely different product. It will be a high-end electrical power analyzer, the PW8001. And that will be on Thursday, October 21st, starting at 10 o'clock in the morning, Central European time. Hopefully, we can see you there again. And we wish you all a very nice week, afternoon, and hope to see you soon back with us. Thank you. Bye-bye.
Thank you.